Today my class is on magnetic field on the axis of a circular coil carrying current. From this equation we have to calculate the magnetic field at the center. So first we draw a diagram. This is a circular coil of radius r. We consider an external point P on the axis. The distance between center to the axial point, that is x, and for small segment, that is C and D, small segment, that is dl, C to P, that is u, and D to P, that is u. So from this equation, from this diagram, we have to easily calculate the equation. So let a circular coil of radius r and consider a point P on the axis. The separation between center of the coil and point P is, that is x. We consider to small length, that is dl, at C and D. So for small length dl at C, the magnetic field at point P is dB equal to mu0 by 4 pi I dl sine 90 degree, because this angle, this and this makes an angle for 90 degree. So by u square. So dB equal to mu0 by 4 pi I dl sine 90 by u square. Next, we can write dB equal to mu0 I dl by 4 pi u square. So dB has two components. dB has two components. Number one, dB cos theta. Number two, dB sin theta. dB cos theta, that is vertical component. dB sin theta, that is horizontal component. And for for small length dl at d, small length dl at d, the magnetic field at p has also two components, that is dB cos theta, number 2 dB sin theta. dB cos theta, that is vertical component, dB sin theta, that is horizontal component. So next we have to know, from this diagram we can get, that is dB cos theta and dB cos theta, this has same value but opposite direction, so this component will be cancelled, only this is the value exist. So vertical component cancelled. So two vertical components, that is dB cos theta will be cancelled, so two vertical components will be cancelled, hence the resultant magnetic field at point P is, that is B equal to summation of dB sin theta. So summation of mu 0 by 4 pi I dl by u square. From this diagram we get, that is sin theta equal to, we can write, that is r by u. So sin theta equal to, we can write, that is r by u. This is r, this is u. So r by u. So mu 0 by 4 pi, this is I cube into r, that is, so summation of dl. Then we can write mu 0 I by 4 pi, this is r by u cube, so this is 2 pi r. So we can write, that is mu 0 by 4 pi I r square by u cube. So u, that is root over r square plus x square. So u equal to r square plus x square, that is half. So r square plus x square, that is 3 by 2. This is the value of u cube. So b equal to mu 0 by 4 pi, this is I r square. So r square plus x square, this is 3 by 2. So this is the value. So if the circular coil contains n number of turns, if the circular coil contains n turns, so we can write that is b dash equal to mu 0 by 4 pi n I r square by r square plus x square, that is 3 by 2. This is the value of b dash. So at center of the coil we can write that is x equal to 0, so we can get that is b1 dashed, so mu 0 by 4 pi, this is the value, here we get that is 2 pi, here we get this is the value of 2 pi, so here we get this is the value 2 pi, so hence here we get this is the value 2 pi, so we can write, so by sorting, so mu 0 I r square by 2, that is r square plus x square 3 by 2. So here mu 0 n I by 2r, this is n terms, this is n terms, and if I get a single term, for single term that is we can write that is b1 समान mu 0 I by 2r. So today we have learned this is the value of circular coil.